Controlling CO2 levels on the station reduces the likelihood of crew members experiencing symptoms of CO2 buildup, like fatigue, headache, breathing difficulties, strained eyes, and itchy skin. The solution is the thermal amine scrubber, which reduces loss of water vapor and recovers CO2 for use in electrolysis to produce oxygen.
Recovering water from urine is a process that is critical to supporting larger crews for extended missions. Urine is collected, preserved, and stored for processing into water through a system called the Urine Processor Assembly, or more simply UPA. The result is a concentrated brine solution. The newest add-on to the system is the Brine Processor Assembly, which aims to recover up to 98% of water from that brine.
A mini-ion DNA sequencer was recently placed on the I.S.S. It is used to characterize the microbial populations on board and to detect changes in the crew's DNA. An active aerosol particle sampler is also used to characterize the dust and other particles.
Spacecraft atmosphere is monitored with a miniature mass spectrometer. It measures the major constituents of the I.S.S. air, including gas contaminants. The unit will sound an alarm if limits are exceeded.
Hira is a system that will be launched in 2020, and its task is to develop solutions to mitigate radiation-related challenges of the human exploration beyond Earth's orbit. Data collected about potential levels of radiation will help design safer vehicles, spacesuits, and all operations associated with crewed deep space missions. The design of current spacesuit is 40 years old. New spacesuits need to offer more mobility on a rover or habitat, so the new spacesuit series have better joints and are rear entry suits that allow crew members to ingress and egress quickly.
For crew health and performance, exercise equipment is necessary, but it needs to be small. There are currently two systems being demonstrated on the I.S.S, the Atlas, which is built by the US, and the U4D, which is a European system, but basically both use a similar range of motion. It's a kind of squat exercise performed using elastic bands instead of weights to provide the resistance.
Soil is too dirty for the I.S.S, so engineers at Sierra Nevada Corporation developed the Astro Garden, a next-generation vegetable growth unit in which water and nutrients are delivered directly to the roots of the plants. NASA is also studying the effects of microgravity on the propagation of large-scale fires. This is a very risky task to be carried out on the I.S.S, so testing is performed on resupply vehicles after they leave the I.S.S and re-enter Earth's atmosphere. These are some of the latest tests carried out inside the I.S.S, but even more audacious projects are underway to develop infrastructures for the free space outside of the I.S.S. Altogether, these projects will allow to return astronauts to the Moon by 2024, have a sustainable presence by 2028, and create the basis for traveling to Mars and beyond. More importantly, these technologies will also help to create products and services that will improve the quality of life for people on Earth.